So what they want to do today is they are going to show you some of their favourite and most exciting experiments. So Mr. Sheldrick's on the physics side and Mr. Lowe on the chemistry side. We're going to leave it to you to decide if you agree with Mr. Sheldrick or Mr. Lowe.
Okay, kiddies. It's not quite Nick and Dom, it's Chris and Dom. So we've got, with the cards when we do the voting, we were trying to be sort of intelligent about it. We failed, but we thought of red C, green P. So if you like Mr. Lowe stuff, lift up your red card. Not yet. Hold on. It's not anything yet. So what we're going to do, when you do a little bit of voting, we'll do a pair of demos. You can then decide which one you prefer. Obviously, if you don't vote for me, I'll cry. Anyway, we're going to start off with a little bit of electricity actually leading on from the spark generator. We're going to try a little bit of that, and I'll be honest, I'm going to turn off the microphone because I'm just going to shout very loudly at this point. So, over in my corner, I have a thing called a Van de Graaff machine. It pulls apart atoms and gets hold of those things called electrons that we were talking about just a moment ago in our last talk. Those electrons, they're a little like tiny magnets, and they do just like magnets. They like to attract, they like to repel. Most of all, they like to jump. So if I just get my little machine ready, I'm just going to make sure I've got everything switched on, and hopefully, there we go, then it's starting to move into action. In a moment or two, it's going to start making some strange noises. And in fact, it seems to be upsetting the machine over there, which may be no great surprise whatsoever. So, you can hear something going on over in my corner. You may not be able to see it. You can't get everything entirely black in here. We've discovered if we turn off all the lights, you can't turn them back on for 10 minutes for some bizarre reason. But anyway, now we've got a machine that's clicking away, what I'm going to do, I've already had to pre-select a volunteer because I was looking for a nice young lady with medium to shoulder length hair, and I've already got one. So can I have my Wollaston volunteer down here? Because I'm just going to electrocute her for your entertainment purposes. See that spark? It's going to be going through her in a minute. Right then, turn off the machine. Can you stand yourself nice and carefully on the polystyrene? And then that's my safety. By the way, that is the safety aspect of all this. Right then, I wouldn't touch it yet, I'm going to touch it first. Get it out. Right, can you put your hand on the top, please? It's not going to spark you yet. Right then. Now, because they act like magnets, remember two things about magnets, they attract and repel. We're going to be looking at repulsion in this experiment. So I picked a lady with nice long hair because we're going to have some fun with her hair. Turn on the machine, make it go. Now, if you'd be so kind, every few seconds, do a bit of a L'Oreal because I'm worth it flick, and slowly see what's happening. Slowly see what happens to her hair. Ever so slowly, the hair's going to start to lift up. These little electrons are actually like magnets, are going to start repelling from each other, and you can just start to see little wisps of hair. Give the hair a bit more of a shape, please. You can start to see, stand up, because they're repelling from each other. You've got to imagine, these are being caused by tiny things, smaller than even an atom. And up until, a few tens of years ago, we thought the atom was the smallest thing available. So, her hair is now standing up beautifully. Right then, now this is the fun bit. It's called, general thing is called static electricity. And the word static means it finds it difficult to move. Now this is really odd. As I turn off the machine, watch the hair. Turn off the machine, the hair stays the same. Very carefully lift your hand away from the machine. So she's now not touching anything. She's still got it. You can tell because the hair is still caught like photographer, please. Right then, now, young lady, can you put your finger up in the air like that? Right, you ready for a shock? Pity, it's going to happen. Okay. One, don't shake. Let's make it worse. 1, 2, 3. Now, look what happens there. Every time we give her a shock, the hair goes down. We should be able to get at least one more shock out of normal. There we go. Look, hair's going to normal. You can walk away safe and sound. No problem at all.
Okay guys, that's my turn. So it's chemistry now. Remember that word, chemistry. But before I do it, I need to speak to students at Urchiston because I've been told to ask you about jelly babies. Somebody tell me something about what's going on with jelly babies, yes? So you've got to look after them for a week.
Yeah.
So if I get this right, you've got to look after them and take care of them for a week.
Yeah.
Oh dear. Okay, in that case, guys, you might need to look away when I do this demonstration. Because what I'm going to do...
He's going to kill a jelly baby.
What I'm going to do is sacrifice a jelly baby in the name of chemistry. Okay, this is my plan for today. Okay, guys. Now I need your help though, because here I've got a red one, I've got a yellow one, and I've got a green one, and I need to decide which one is going to be sacrificed. Okay? So this involves everyone. So hands up for yellow.
No.
Okay, that's quite a lot. Hands up for green. Okay, yellow winning so far. Hands up for red.
Yellow.
Yellow's going to get it.
It's going to make him scream because I've done this project before.
Well, funnily enough, it's the same as earlier today when I did this. Now we've got a second decision to make, because obviously a jelly baby's got a head and it's got feet. So is it going to go down head first into the tube, or is it going to go feet first? Let's see if you're...
Feet first.
Hands up for head.
Yeah,
Hands up for feet. Okay, so head wins. But I've got to say, that's very fair of you, because that means it's going to get a quick death.
Yeah.
So it's going to go in there first.
They'll be dead straight away. I'll have to tell my in my
Now, occasionally the jelly babies get a little bit too angry and overexcited, so I'm going to wear a face mask to protect myself. Okay, it was head first, wasn't it?
Yeah.
I'm so sorry for it. No. She should sacrifice something else. Darcy, they need to take some sugar.
Oh, this is some good footage.
Go up to the Zoom out.
Right guys, that energy that's given off, that's why we eat them. Okay, well, they also taste very nice. We want that energy because that helps us move around. Yes? It's potassium chlorate. What it does basically is adds oxygen. Okay, yep. That's because of the potassium in potassium chlorate. So potassium, when you burn it, gives off a purple colour. So like fireworks and stuff, you can see different colours. But often it's different metals that are in there, so different colours.
I think time to do a little bit of voting. Green C, no, that's it. Green P, red C. Yes, so chemistry, lift up your red cards. Physics, lift up your green cards.
Red. So badly red.
Chemistry 1-0. Okay. Next pair of experiment. Oh, thank you. You're lovely. You may come to Wollaston. Right.
I don't Wollaston anyway.
Got the next one.